Mythbusters is next, only on the Discovery Channel.
We have minutes of experience. Try this at home.
I think it's don't try this at home.
Oh.
Coming up on Mythbusters. Will an arrow fired at close range shatter on impact? Can a high school science experiment have explosive results? And will microwaving flat soda bring its fizz back? Who are the Mythbusters? Adam Savage.
I go for the Mythbusters cola every time.
Jamie Heineman.
Most of the time you're wrong, though.
Together, they have over 30 minutes of special effects experience. Joining them are Tori Balachi, Carrie Byron, and Grant Imahara. They not only tell the myths, they put them to the test.
Okay, Jamie, what myth are we going to be testing today?
We're going to do a Robin Hood myth.
All right, it's archery, and we get to work with stuff. It sounds like fun.
Whatever. The myth is that a hunter is hunting wild game with a compound bow. And what happens is he gets too close to it, and when he shoots at it, the arrow shatters on impact, allowing the animal to get away. What they're saying is that it's better to use a traditional bow because it doesn't put as much force behind the arrow and allows it to penetrate properly.
Okay, kind of makes sense, you know, firing arrows at dense objects at close range, you know, it can cause some difficulties.
Yeah. Well, what I was thinking is we would run 2 trials, one at a short distance and one at a long distance. We would use a compound bow and a traditional bow. We would also use carbon arrows because they're the most common for hunting. We'd shoot them at ballistics gel.
Where are we going to be shooting all this stuff at?
Well, my friend has a ranch and he's pretty much an archery expert, so I figured we could test him out there.
All right, it sounds like a road trip to me. Let's get going.
Road trip is right, Adam. The guys head out to the countryside so they can safely fire the bow.
Now, since we don't have an archery range back at M5, we're here at McDonald Ranch, where we're going to have a professional archer teach us how to shoot these bows.
Jamie Heim.
Nice to meet you. I'm Savage. Nice to meet you. Now, what this myth is saying is that at such a close distance, an arrow being fired from a compound bow with so much force behind it and such little distance will shatter on impact. Whereas with a traditional bow, since it's not going as fast, it'll go straight through.
Have you ever heard about the myth of somebody hunting with a compound bow, and when they go up to shoot their game, they're too close to it, and when they shoot at it, the arrow, when it hits them, it shatters because of the high forces?
Actually, yes, I have heard of this. It's never happened to me, but I heard stories from other hunters about this happening to them.
Looks like this myth has already made its rounds, but could it possibly be true?
What you got? You got 2 bows here. You got a traditional bow and a compound bow.
Yeah.
Can you tell us about these bows here?
Okay. What we have here is the compound. Alright, the compound has a cam and limbs. Well, the traditional only has just the limbs. Now, this compound will travel way faster and have way more force than what the traditional will, for the fact that whenever it's released, the cam will help bring force into the arrow along with the limbs. Now, with just the traditional, all you have working towards the arrow is just the limbs.
So do we get the chance to shoot these things?
Yeah.
What myth could possibly deal with this?
Well, the story has it that if you take a bottle and put a burning piece of paper inside of it, and then you take a hard-boiled egg and set it on top of the bottle, it will actually suck it inside of the bottle.
Oh yeah, I heard about this. And like if you add a puff of air into it, it'll actually shoot across the room.
Okay, so there's this myth out of Rhode Island where students are doing a science experiment with a bottle and eggs. So supposedly, one of the students was doing this and is shot across the room and hit another student and knocked them out of their chair.
Carrie ignites a piece of paper and drops it into the bottle in order to burn most of the oxygen. This creates a low pressure inside and causes the egg to be sucked in. Tori puffs air into the bottle to create a high pressure and force the egg out. Will this pressure be enough to actually cause the egg to come flying out of the bottle across the room?
So there's definitely enough pressure to have the egg fall out of the bottle, but what we really need to find is if there's enough force to give it enough velocity to actually hit somebody out of their chair.
Adam and Jamie are testing the myth that firing an arrow at close range will cause it to shatter on impact due to the high forces.
We set up this ballistic gel in front of this target, and that's how we're going to test. This ballistic gel is awesome. It represents the tissues and skin of the animal.
We're going to run 2 trials, one at the 20-meter line and one at the 2-meter line, and compare the results.
Additional bow, 20 meters in 3, 2, 1.
Compound bow, 20 meters in 3, 2, 1.
As expected, the arrow fired from the compound bow penetrates more than the arrow fired from the traditional bow, but now it's time to move up to the 2-meter mark.
Additional left-handed bow from 2 meters, 3, 2, 1.
The difference is obvious, but will the arrow fired from the compound bow really shatter on impact?
Compound definitely has more force behind it, so I think there's a little bit of truth to this myth. Jamie will probably think otherwise.
The myth that an arrow shot from a compound bow will shatter on impact at short range is completely ridiculous. It's going to go through either way because it's such a high force going through such a small surface area.
It's going to go straight through, no problem.
All right, compound bow, 2 meters in 3, 2, 1.
The arrow goes straight through and doesn't shatter. Looks like this myth is busted.
Well, Jamie, that was quite the opposite of what we thought it was going to turn out like, huh?
Well, I thought it was going to do what it did. I mean, you got so much force just in this little point right here. Almost anything's going to make it penetrate. I mean, if I threw it like this, it probably wouldn't. But with a bow, it's going to go through. So what myth do we have next?
Well, it has to do with what was once in these cans. Also, what was in these cans? Yeah, there was a myth about this gentleman who got sick and tired of always wasting his soda because they got flat, so he had to throw them away. So he decided to take matters into his own hands and stick them in the microwave. This is kind of similar to water, tap water. If you were to microwave that, and you would see air bubbles going to the top. And that's all the impurities, getting out of it. So, in a sense, that's what this man was trying to do with his soda, trying to get all the carbon dioxide out.
Well, I don't know. I mean, all the carbon dioxide has already escaped from the soda, so...
But that's why when you heat it up, it makes sure that every last particle has escaped. The way I was thinking of testing this was we get several different types. We get cola, diet cola, caffeine-free diet cola, some ginger ale, maybe some diet ginger ale, Make sure we cover all the bases so we don't make any mistakes. We'll just shake them up, leave them open overnight, 24 hours, and we'll bring it back here to microwave them.
While the soda sits open at M5 for the next 24 hours, let's check back with the build team. The build team is testing a high school experiment gone wrong.
So we have this bicycle pump here, and what we're going to do is we're going to hook up a funnel to it so we can concentrate the airflow into the bottle. So if everything goes according to plan, we should be able to just move the air or the bottle out of the way, and it should be able to launch across the room. Excellent.
The experiment is conducted the same way, only instead of Tori blowing air into the bottle, it will be forced in with the bicycle pump. This is in hopes that it will create an even higher amount of pressure and launch the egg across the room.
Here we go, ready?
It appears that the egg had a little more force, but not enough to confirm this myth.
So what do you guys think about this myth?
Well, I think, we got the egg to come out of the bottle, but we didn't get to shoot across the room.
Yeah, the idea of it knocking somebody out of their chair is just completely ridiculous.
I'm calling this busted.
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 The
Adam and Jamie are testing to see if microwaving flat soda will bring its fizz back.
I think first we should start testing, we should microwave the water, because then we can see how long it takes to boil, if we can boil it, and then how long we have to microwave it to boil.
So Adam places a cup of water in the microwave to get a base reading of how long it takes to boil. And at about 2 minutes, it begins to boil.
Now this is our workstation. We're going to be sitting back here behind this plexiglass shield, which will keep any shrapnel from flying at us, just in case. Jamie's going to be pouring me some soda. And then we're going to be coming up here, and I'm going to put this in here for 3 minutes. Because when we tested the water, it started boiling about the 2 minute, 15 second mark. So we're just going to go to 3. And that is how we're going to test this myth.
Jamie pours a glass of regular cola to start the experiment. And at about the 2 minute and 45 second mark, the cola begins to bubble over.
Oh, look at that. Look, it's bubbling. It's bubbling. Look, that's awesome.
Maybe there's something to this myth.
Could this be the remaining amounts of carbon dioxide making the cola fizzy again?
Ooh, I'm so excited. Let's go get our super carbonated soda. What is this?
It's flat, isn't it?
Yeah. This is ridiculous.
There's more to be upset about, Adam. The rest of the colas tested did not become fizzy after microwaving. Even the control, which went in fizzy, came out flat. A sure sign that microwaving flat soda will not bring its fizz back.
I told you microwaving it would get rid of the carbon dioxide.
I do, however, remember you agreeing with me at one point.
With what was that one point?
I'm sure they'll get it in editing.
Maybe there's something to this myth.
Now we have a bunch of crushed cans here, and that'll add some density and some surface area to the mix. So we're just gonna stick these in this microwave, set the timer for about, I don't know, it's just half hour or so, and we'll see what happens. All right, you ready, Jamie?
Yep.
Last danger, clear the area! Last danger, clear the area!
All right,
3, 2, 1. Whoa! Awesome! I don't see your microwave anymore, Jamie.
As well you shouldn't, Adam. The microwave has exploded and remarkably disappeared.
Where'd it go? Well, you know, Jamie, I don't think we just busted a myth today. I think we kind of created a public service announcement. Don't put a bunch of cans in your microwave.
Yeah, this myth is completely busted. I mean, when we put the control in, which had carbon dioxide in it, and microwaved it, boiling it took all the carbon dioxide out. So we got opposite of the results that we wanted.
Yeah, and you know, even if this myth were true, who would want to drink hot fizzy soda anyways?
Yeah, well, at least you can, if somebody asks you what it's like to microwave a bunch of cans, you can say,
Yes, I have, but not only did I do that in the name of science. Because this myth